All right. Yes?
So what if you have the eigenvalues at 1 or minus 1?
What if you have eigenvalues at 1 or minus 1? That's a very good question.
Shouldn't, like, that's like, never mind.
That's actually what we saw in midpoint rule. So let's analyze the midpoint rule. So midpoint rule have an eigenvalue exactly at, I think it's minus 1. Let me just analyze it. So you have un plus 1 minus un minus 1 divided by 2 delta t equal to what? If you want to analyze zero stability, yes, 0. Okay. Then how do I convert that scheme, which is basically un plus 1 equal to un minus 1, into matrix form? Somebody just give me the matrix.
0, 1, 0, 0.
0, 1, 0, 0. Are you sure?
0, 1, 1, 0.
0, 1, 1, 0. Yes, un has to be equal to un. All right. So this is the matrix. So now my A for midpoint is 0, 1, 1, 0. And I of A gives me minus 1. Oh, I actually have a minus 1 and 1. All right. Okay, so I get an eigenvalue at minus 1. Okay, how about forward Euler? Forward Euler is un plus 1 minus un divided by delta t equal to 0. So I get un plus 1 equal to un, right? So the matrix is what? It's just the 1, right? It's the simplest. So what's the eigenvalue of? It's just 1. It turns out for any ODE solver, if you want the analytical solution of du dt equal to 0, you have to have an eigenvalue at 1. I mean, there is no escape from that, because otherwise you wouldn't be solving the equation. Du dt equal to 1, du dt equal to 0 means what? Means u is a constant, right? And if you want the scheme to be accurate, you have to have an eigenvalue of 1 to keep basically the constant to be a constant. So you need an eigenvalue equal to 1 always. It's the other eigenvalues that becomes tricky. So for midpoint row, you have a minus 1 eigenvalue. A minus eigenvalue means what? So going back to our previous case, if you initialize with forward Euler and use midpoint, okay, what you see here is the midpoint row jumps between 0.95 and 1. This constant oscillation, when you have a small error in the initial condition, is characteristic of the minus 1 eigenvalue. So what does minus 1 mean? It means like for that particular error mode, which corresponds to the corresponding eigenvector, every time I advance, the error gets flipped in this sign. So that is why you get goes down and then goes up and then goes down and goes up, right? So that's what the minus 1 eigenvalue is doing. It's basically creating these oscillations. It's also why when I actually solve this with midpoint rule, I'm gonna run for the Euler and run midpoint rule, I get these oscillations. These are also grid by grid oscillation, characteristic of an eigenvalue minus 1.